2. This is just the beginning of the first half of 11, which we're just going to split 11 into two parts. And it's simplifying rational expressions. This is the basic fundamental idea we're going to need for the rest of the chapter. So the first thing I'd like you to do is to use the glossary in the back of the book, and I'd like you to define factor and define term. And write those down because there's a very important difference that you need to see and understand about those two. So push pause and please find the definition of factor, okay, or factors, it's listed, and then find the definition of term and write those down. Push pause now and come back when that is done. Okay, the biggest thing about factors are that they are numbers that are multiplied together. They are part of multiplication, and terms are part of addition. And subtraction is addition. Remember, you can always change a minus to plus a negative. So terms are things that are added. Okay. The next part we're going to talk about is we're going to go back in this idea of simplifying to something you already know, and you simplify fractions. And if I gave you these three, I'm sure you could do them no problem. When you're doing that, remember that you weren't looking for something that you would subtract from both or add to both. You were looking for something that divides into both, or a common factor. So one way to look at it, and again, I'm showing you this. I know you can do it in your head, but I'm showing you this way so that as I take it into a more difficult problem, you'll see that it's exactly the same thing you've been doing. So what I did here is I did the prime factors of 24 and the prime factors of 36. And we've talked about prime factors already, so that shouldn't be completely unfamiliar. 2 divided by 2 is 1, so I can cancel those. 2 divided by 2 is 1. 3 divided by 3 is 1. Okay, so I'm left with 2 over 3. Okay, and you could have found the exact same thing by just dividing both by 12 and simplifying. Over here, 15 and 35, again, I did their prime factors. I found their common factor was exactly what you were doing here. You were dividing both by their common factor. So if I cancel those, the simplified fraction is 3 over 7. And in the next one, I did the same idea. I did the prime factors of 16, prime factors of 24, and I'm going to cancel the common factors. And again, I'm left with 2 over 3. So I'm not saying the way you've learned before. I'm doing exactly what you learned before. You looked for the biggest number that could go into both of them. You divided the numerator and denominator by that number. I'm doing that same idea here, just in a little bit different way in the way it looks. And I'm doing that because once I put x's and everything else in there, I want you to see. Okay, and then I wrote a note down here. You can cancel factors, but you cannot cancel terms. And remember, we defined those in the previous slide. So here, I can cancel these and say it's 4 over 3. But look, if you try to cancel terms, let's look at it normally. You would say 4 plus 4 is 8. 4 plus 2 is 6. And then you wouldn't say what adds to 4 and adds to 6. You would divide them both by a common factor. And you know, if you were to do this, you should get 4 over 3. Now, if you try to do that by canceling like terms, oh, look, this is red is wrong. So red is the wrong thing to do. If you canceled those, you would get 4 over 2. That's 2. That's not right at all. So that's not right. That's not right. You cancel factors, you do not cancel terms, and that is going to be a huge idea in this chapter. So now I made it just a little bit more difficult, but you did these in the exponent chapter in chapter 9, so I don't think these are too difficult. Again, you can split these up so that you have 15 over 25, if that helps. Some of you, my visual people, it'll help to just block it out. And then the x to the 8th over x squared. Okay? If you simplify 15 over 25, that's 3 over 5. X to the 8th over x squared. Now, some of you kept writing this as a second fraction. That needs to stop. I was nice with that on the chapter 9, but it needs to stop. I have 8 x's across the top. I have 2 x's on the bottom. So there's going to be canceling, and I'm going to have x to the 6th left on the top. Okay, down here, it's the same idea. What are the factors? The factors are x plus 5 and x minus 4. These are what is being multiplied. This is what's being multiplied here. I can cancel factors that are alike. Those are out. I'm left with x minus 4 over x plus 4. Now, some of you might say, well, can I cancel the x's? No, those are terms. You cannot cancel terms. We talked about that before. Some of you it might help if you kind of put parentheses around it. For some of my students in the past, that's helped as kind of like a force field to remind them I can't go in and cancel these x's and I can't cancel these 4's. This is your final answer of that simplifying. So push pause. I'd like you to try the right side on your own. Okay, on this problem, if you simplify the 25 and the 10, you should get 2. X squared and x cubed. I'm going to have canceling. I'm going to have an x left on the bottom, because the 2 x's on the top will cancel and there'll still be 1 x on the bottom. Y to the 8th over y to the 5th. Okay, there's going to be canceling and I'm going to be left with 3 y's on the top. So that's your final answer. And down here, I look for the common factors, what's being multiplied, and I'm left with x plus 3 over x plus 5. This is my final answer. And again, you can put the parentheses around it if that helps you to remember not to cancel to 3/5. This is your final answer. On the next slide, I just added one step. So the first thing you're going to do is look at the numerator and look at the denominator. And you're going to factor everything completely, just like we did in chapter 10. So in the numerator, you're going to factor it. Is there a GCF? No. Can I factor it into 2 binomials? Yes, you can. Oh, look, there it is. The denominator, is there a GCF? No. Can I factor it into 2 binomials? Yes, I can. There it is. So after you factor everything completely, it's just like the problems you did before. Here are my factors, x plus 6 and x plus 1. Here are my factors for the denominator, x plus 6, x minus 6. What do they have in common? Cancel it. So my answer is x plus 1 over x minus 6. I'd like you to push pause. I'd like you to try these other 3. So factor them completely and then cancel their like terms. So push pause now. Okay, I have the answers here. You can see the factored version of the numerator and the denominator. I will cancel their common factors. This is my final answer. Over here, I factored the numerator and the denominator. I'm going to cancel the common factors. This is my answer. Again, I factored, cancel. That's my answer. If you need to push pause here because you need to check the factoring or check your answer, go ahead and push pause. I'm going to move on, but push pause if you need to check more answers. In this particular one, this one looks, and some people say, oh, there's nothing you can do, or they start to cancel terms. Please remember these are being added or subtracted. You might want to throw up parentheses just anytime you see addition or subtraction to remind yourself, I can't start canceling yet. I understand there's no squared, so some of you might say, well, there's nothing I can do, I can't factor it. But remember, look for a GCF first. Look at the numerator. Is there a greatest common factor there? Yes, there is. Look at the denominator. Is there a greatest common factor there? Yes, there is. So now I have factors. I'm going to cancel. I'm left with 10 over 8. However, 10 over 8, I can simplify further to 5 over 4. So my final answer is 5 over 4. So again, I'd like you to try these 3. So please push pause, try these 3, then come back for the answers. Okay, the answers are here. Again, in the first one, there's addition or subtraction. Again, if you want to put the parentheses there, so remember not to start canceling. These are terms. This is being added with this. Cancel your common factors. This is your answer. In this one, some of you may have had a little trouble here, but if you use your area model or something, this does work out. Here are your factors. Cancel the common ones. This is your answer. This one was a little tricky because you had a lot to do. So you'll see here in the first part, over here, I factored out a GCF. And some of you may have had trouble with this because you didn't think to look at the GCF first. So factor out the GCF. Then I went to this step where I factored the binomials that were left inside. Cancel the common factors. I can also cancel the 3 and the 6. Okay, so I'm left with, on the numerator, I'm left with an x minus 1. In the denominator, I'm left with a 2 and an x plus 1. And there's my final answer. Again, if you need to push pause to check factoring or check something else, push pause now and check the answers, but that is the end of the problems for 11-2.